Hi, this is Professor Nabozny, and this video is to give you some basic instruction in converting binary numbers to decimal numbers. The first thing we're going to do is create a bit grid. We're basically creating a rectangle, and then we're going to divide it into 8 parts. Because we're dealing with binary numbers, we're going to deal with the number 2. And so we can put the number 2 into each place. And then we're going to set the exponents. So in the very first square, we're going to do 2 to the 0 power, then 2 to the first power, 2 to the second, 2 to the third, 2 to the fourth, 2 to the fifth, 2 to the sixth, and 2 to the seventh power. As you might remember, any number taken to the 0 power equals 1. Any number taken to the first power equals itself. So 2 to the first power will equal 2. 2 to the second power will be 4. 2 to the third power will be 8. 2 to the fourth power will be 16. 2 to the fifth is 32. And then 2 to the sixth power is 64. And finally, 2 to the seventh power is 128. Don't be confused that we've got 8 places and that this last one is 2 to the 7th power, because remember that in that very first square we've got 2 to the 0 power. Now that we know what all the values are, so in our byte, because 8 bits equals byte, eight bits equals 1 byte. Each one of these bit places has this value. So this first bit place is worth 1. This one is worth 2, 4, 8, 16, 32, 64, and 128. So given any binary number with any binary byte, we can calculate what the decimal value of that byte is. So if these are all zeros, then our decimal value is 0. If each one of these is 1, then we can add up what the value corresponding to each one of those places is. So we would have 128 plus 64 plus 32 plus 16 plus 8 plus 4 plus 2 plus 1. So 128 plus 64 is 192, plus 32 is 224, plus 16 is 240, plus 8 is 248, plus 4 is 252, plus 2 is 254, and finally plus 1 is 255. So these are the two limits. If they're all zeros, then our answer is 0, and if all the bit places are 1, then the answer is 255. We cannot have an 8-bit binary number that is greater than 255. That is the maximum. So we can create any number in between 0 and 255 just by adjusting, which ones of these bit places are worth 0 and which ones are 1. So, for example, if I use this 0, 0, 0, 1, 0, since I only have a 1 in the 2-bit place value, then that number equals 2. If I do this, then that number equals 1, because I've only got a 1 here. If I do this, then my answer is 3. So in this case, I've got 1 plus 2. This is 2 plus 1, and that equals 3. Continuing on, if I want to make a much larger number, I could do this. 1, 0, 1, 0, 1, 0, 1, 0. Okay, so I've got a 1 in the 128 place. I've got a 0 here, so that's going to be 0. I've got a 1 in the 32 place, 32. I've got another 0. I've got a 1 in the 8 place, another 0. A 1 in the 2 place, that equals 0. So now I just need to add up what I've got here, and if I want to simplify it, I can do 128 plus 32 plus 8 plus 2. So 128 plus 32 is 160, plus 8 is 168, and plus 2 is 170. So my answer is 170. So 10101010 equals decimal value of 170. One of the checks you can use to verify whether you've got, it's not going to tell you whether the answer is correct or not, but one of the checks you can use is kind of like a quick logic check, if you will, is if this last bit place value is 0, then the number must be even. It must be divisible by 2. If this last bit place value is a 1, then this number must be odd. So for example, if this were our number, so there's our binary number, and we've got all zeros. So we've got an 8 plus 4 plus 2 plus 1. 8 plus 4 is 12, plus 2 is 14, plus 1 is 15. We've got a 1 in the last bit place value, and so this number is odd. So this, like I said, if this value here is a 1, then the number must be odd. If this value here is a 0, then the number must be even. So just a quick check to validate whether you, it's not going to tell you for sure that you have the right answer, but it can at least tell you if you're completely wrong, if you've made a mistake. So now I'm going to pass out the instruction sheet so that the practice worksheet, so you can practice some of this on your own.